47 hours. Henderson Field, Guadalcanal. Captain Joe Foss can hear them coming. The sound starts as a rumble, distant, mechanical, growing louder over the jungle canopy. Japanese Betty bombers, maybe 20 of them, riding the dawn light down from Rabaul. Foss is already running toward his F-4F Wildcat, boots slapping through what used to be a runway and is now 6 inches of volcanic mud that sucks at his feet like something alive. Henderson Field, named 3 days ago for a Marine pilot killed at Midway, is barely recognizable as an airfield. The Japanese built it, the Marines captured it on August 7th, and now the South Pacific is trying to reclaim it. Last night's rainstorm dumped 4 inches in 2 hours. The coral and dirt runway, packed hard by Japanese engineers over months of work, has dissolved into a chocolate-colored swamp that stretches 3,800 feet down what used to be a relatively flat piece of Guadalcanal's northern coast. Foss reaches his Wildcat. The fighter sits canted at a 15-degree angle, left wheel buried to the axle, right wheel perched on what might charitably be called solid ground. Aviation machinist's second-class Dutch Schaefer is already there, hands black with grease, face twisted in concentration as he tries to rock the aircraft free. "She gonna fly, Dutch?" "She'll fly if we can get her to the goddamn runway." Schaefer doesn't look up. "Problem is, Captain, the runway's underwater." "It's not underwater. It's worse. Water you can drain, pump, divert. This is volcanic soil, rich, black, fine-grained, mixed with rain and churned by propeller wash and landing gear into a substance with the consistency of wet concrete and none of its structural integrity. Every aircraft that's landed in the past 12 hours has sunk. Every takeoff attempt has sent mud spraying 100 feet into the air, clogging engine intakes, coating windscreens, adding weight that turns fighters into death traps. The Betty bombers are 3 minutes out now. Foss can see them, dark specks against the pink dawn, flying in perfect formation at 18,000 feet. Henderson Field has 19 operational Wildcats and 12 SBD Dauntless dive bombers. Operational is a generous term. Half are stuck in the mud. The rest are scattered around the perimeter, parked on anything resembling firm ground. Japanese revetments, patches of crushed coral, the roots of coconut palms. "Get her moving," Foss orders. "I don't care how." Schaefer waves over 3 Marines from the ground crew. They set their shoulders against the Wildcat's fuselage and push. The aircraft rocks, tilts, and the left wheel comes free with the sound like a boot being pulled from deep swamp muck. They push harder. The fighter slides forward 6 feet, then 10, trailing mud from both wheels. Foss climbs into the cockpit, still muddy from yesterday's sortie, and fires the Pratt & Whitney radial engine. It coughs, catches, roars to life with a blue-gray cloud of exhaust. He taxis toward the runway. Taxis is the wrong word. He wrestles, fights, coaxes the Wildcat across ground that shifts and liquefies under 5,000 pounds of aircraft. Other fighters are doing the same, converging on the runway's southern end where the mud seems marginally less deep. Major John L. Smith's aircraft is already there, engine at full throttle, prop wash blasting a crater behind him as he tries to build enough speed to break free from the surface tension. Smith's Wildcat lurches forward. 10 knots, 20. The mud is everywhere, coating the wings, spraying from the wheels, turning the air brown. 30 knots. The fighter shudders, wallows, and then, impossibly, the wheels break free and Smith is airborne, climbing hard, gear still down and streaming mud like water from a whale's blowhole. Foss is next. He lines up, checks his instruments, oil pressure good, fuel sufficient, mixture rich, and shoves the throttle forward. The Wildcat bucks like something feral. The mud grabs at his wheels, fights him for every knot of airspeed, tries to pull him sideways into the drainage ditch that parallels the runway. 40 knots. He's not going to make it. 50. The stall warning is a whisper at the edge of his awareness. 60. The Betty bombers are overhead now, bomb bay doors opening, and Foss hauls back on the stick with both hands. The Wildcat claws into the air, barely, maybe 20 feet of altitude, engine screaming, airframe shaking, but he's flying. He retracts the gear. Thick globs of mud fall away and banks hard left toward the bomber formation. Behind him, Henderson Field is coming apart. Bombs crater the runway, but the real damage was done by nature. Without a stable surface, the airfield is dying. Marine engineers have tried everything. Crushed coral, gravel, coconut logs laid crosswise to create traction. The rain washes it away. The mud devours it. Aircraft sink. Pilots die on takeoff when their wheels catch in deep ruts and the fighters cartwheel into the jungle. 3,000 miles away, in a Carnegie Steel office in Pittsburgh, a man named James Marston is about to receive a telegram that will change everything. But right now at Henderson Field, as Foss climbs toward the Japanese bombers, and aviation machinist second-class Schaefer watches 3 more Wildcats struggle to get airborne, the problem is brutally simple. They've captured an airfield they can't use. And without Henderson Field operational, Guadalcanal, the first Allied offensive in the Pacific, will fall. The mud is winning. August 28, 1942, 0820 hours. Bureau of Yards and Docks, Navy Department, Washington, D.C. Commander William Painter has a headache that won't quit and a problem that might lose the war. The telegram from Guadalcanal sits on his desk, 4th one this week, each more desperate than the last. Henderson Field is sinking. Marine engineers are working 18-hour shifts trying to stabilize a runway that liquefies every time it rains, which in the South Pacific during monsoon season means twice a day. They've tried everything. Coral excavated from nearby reefs and crushed into aggregate, timber mats constructed from coconut palms, even Japanese steel drums filled with rocks and laid flat to create a semi-solid surface. Nothing works. The volcanic soil is too fine, too water-retentive. It doesn't drain, it absorbs. Add the weight of a laden F-4F Wildcat, 5,895 pounds, with full fuel and ammunition, and the surface simply gives way. Yesterday, an SBD Dauntless broke through the runway during landing rollout, nose gear collapsing into a sinkhole that formed in the 30 seconds between touchdown and brake application. The pilot walked away. The aircraft is still there, half submerged, a monument to engineering failure. Painter lights his 3rd cigarette of the morning and studies the specifications again. What the Marines need is a runway surface that can support aircraft weighing up to 10,000 pounds, be transported by ship to remote Pacific islands, be installed by non-specialized personnel in under 72 hours, survive tropical rain, jungle humidity and temperatures exceeding 100 degrees Fahrenheit, flex with unstable ground without cracking, resist corrosion from salt air, be repairable in the field with minimal tools. Oh, and they need it in 6 weeks, maybe less. Painter stubs out his cigarette and reaches for the phone. Get me Carnegie Steel, Engineering Division, tell them it's urgent. September 2nd, 1942, 1340 hours. Carnegie Illinois Steel Corporation, Pittsburgh, Pennsylvania. James Marston thinks Commander Painter has lost his mind. You want a steel runway. Marston says it slowly, like he's explaining physics to a child. A flexible steel runway that can be assembled in a jungle by Marines who've never done construction work in 3 days. 2 days would be better. Painter doesn't smile. The commander flew in from Washington this morning, and he has the look of a man who hasn't slept in a week. We're losing Guadalcanal, Mr. Marston. Not might lose, are losing, right now. Every day Henderson Field is inoperative, Japanese bombers hit our positions without opposition. Every supply ship that reaches the island is a minor miracle. The Marines are eating captured Japanese rice and fighting with ammunition they scavenge from enemy dead. Marston walks to the window of his office. Outside, Pittsburgh steel mills pump smoke into a gray September sky. Carnegie, Illinois is running 3 shifts 7 days a week, producing armor plate for battleships, structural steel for destroyers, tank armor, gun barrels, every piece of shaped metal the war effort demands. They're good at it. They've been making steel since 1892. But a steel runway? That's not metallurgy. That's madness. Commander, with respect, steel is rigid. Runways need to be rigid. You put a flexible surface on unstable ground and it'll buckle under load. The aircraft are already crashing, Painter cuts him off. They're crashing because the runway is mud. What we need is a surface that floats on top of the mud, like a raft, a steel raft. A raft, Marston turns from the window. Think about it. You can't stabilize the ground. The Marines have tried. The rain keeps coming. The mud keeps forming. So stop fighting the mud. Build a runway that sits on top of it, distributes the load, flexes with the ground movement instead of cracking. Steel planks, Marston says slowly, working through the engineering in his head. Perforated to shed water and reduce weight. Interlocking somehow so they don't slide apart under stress. Each plank may be 10 feet long, 15 inches wide. Can you do it? Marston thinks about load calculations, tensile strength, the coefficient of friction between steel and volcanic mud. He thinks about tropical humidity corroding joints, about thermal expansion in 100-degree heat, and what happens when a 10,000-pound aircraft lands at 90 miles per hour on a surface that's never been tested. I don't know, he admits. Nobody's ever built anything like this. Then you'll be the first. Painter stands, extends his hand. 6 weeks, Mr. Marston. That's all the time we have. After that, the Japanese take Henderson Field and Guadalcanal falls. Then the Solomons. Then Australia. You want to win this war? Start by building me a runway. Marston shakes his hand. After Painter leaves, he sits at his drafting table and starts sketching. The basic concept is simple, almost absurdly so. Individual steel planks, each one light enough for 2 men to carry, strong enough to bear aircraft weight. The planks would interlock by male-female connectors along the edges, a raised lip on one side, a channel on the other. Lay them in rows, connect them together. The result would be a continuous steel carpet that could flex and shift with the ground beneath without coming apart. Simple. In the same way splitting the atom is simple once you understand the physics. By September 4th, Marston has a prototype, a single plank, 10 feet long, 15 inches wide, 1/8 inch thick, perforated with 88 holes to reduce weight from 66 pounds to 41. The holes serve double duty, drainage and lightening. Rain falls through instead of pooling on top. The steel is high-strength alloy, heat-treated to resist corrosion. The interlocking mechanism is the hard part. Make it too tight, and the planks won't flex. Too loose, and they'll separate under load. Marston designs a curved lip that allows 3 degrees of angular freedom, enough to accommodate ground movement, not enough to create dangerous gaps. By September 10th, he's built a 100-foot test section in Carnegie's Pittsburgh yard. They park a 5-ton truck on it. The planks flex, redistribute the load, hold firm. They hose it down with water until the ground beneath turns to slurry. The truck drives across. The steel ripples like fabric, but it holds. September 15th, full-scale testing. A Navy F-4F Wildcat borrowed from Naval Air Station Anacostia lands on the test strip at 70 knots. The impact sounds like rolling thunder, metal singing under stress, but the planks don't buckle. The pilot taxis, turns, takes off again. No damage, no deformation. Commander Painter witnesses the test. He doesn't say anything for a long moment, just watches the Wildcat climb away into the Maryland sky. Then, how fast can you make 10,000 of these? 10,000 planks? 10,000 sections. Each section is 5 planks wide, 100 feet long. That's 500 planks per section, 5 million planks total. We need enough to build runways on every contested island in the Pacific. Marston does the math in his head. Carnegie, Illinois can produce maybe 50,000 planks per month if they retool 2 production lines and run continuous shifts. 6 months, maybe 8. You have 3. Painter lights a cigarette. Guadalcanal needs 1,000 sections by November. We're shipping them on the next available cargo vessel. After that, we'll need more for Bougainville, New Georgia, wherever else we're taking airfields from the Japanese. We don't even have a name for this thing. Painter considers. What do we call it? Marston looks at the test strip, at the steel planks gleaming in the afternoon sun, and at the impossible thing he's just built. Steel plank landing mat. Too technical. How about pierced steel planking? PSP, Painter says. Works for me, but the Marines are going to call it whatever they want. He's right. By the time the first shipment reaches Guadalcanal in October 1942, the Marines have their own name for it. They call it Marston Mat, or just Marston Mat, because, in the end, wars aren't won by technical specifications or official nomenclature. They're won by engineers who figure out how to turn mud into runways in under 72 hours. October 14th, 1942. 1420 hours. Henderson Field, Guadalcanal. First Lieutenant Tom Crockett stands ankle-deep in mud, staring at 347 wooden crates like they contain either salvation or his court-martial. The crates arrived yesterday aboard the USS Elhina, a cargo ship that made the run from Noumea through waters the Navy calls the Slot, a stretch of ocean so dangerous they only transit it at night. Each crate contains 15 steel planks, 41 pounds apiece. Do the math. 5,205 planks total. Enough to build maybe 800 feet of runway. Henderson Field is 3,800 feet long. Sir, we're supposed to build a runway out of these? Gunnery Sergeant Pete Kowalski holds one of the planks at arm's length. It's 10 feet of perforated steel, edges machined with interlocking connectors that look like something from an erector set. This is sheet metal. We land Wildcats on this, they'll punch straight through. Navy says it'll hold. Crockett doesn't sound convinced. He's a civil engineer from Sacramento, drafted into the Marines 6 months ago, and his expertise is concrete foundations and rebar, not experimental steel carpets designed by people who've never seen volcanic mud. Orders are to install a test section, 5 planks wide, 100 feet long. If it works, they'll ship more. And if it doesn't work? Crockett looks across Henderson Field. The runway is a disaster, cratered by Japanese bombs, liquefied by rain, patched with coral that washes away every time the sky opens up. 3 Wildcats are grounded right now with damaged landing gear from hard impacts on uneven surface. 2 days ago, an SPD Dauntless nosed over during takeoff when its wheel caught in a rut. The pilot survived with a concussion. The aircraft is scrap. If it doesn't work, Sergeant, we're done. Japanese Navy shells us every night. Japanese bombers hit us every day. Without air cover, we're target practice. He picks up one of the planks. Let's get started. They choose a section near the runway's northern end, 160 feet long, flat as anything gets on Guadalcanal, currently 6 inches deep in standing water from last night's rain. The first challenge is immediately apparent. You can't just lay steel planks on mud and call it a runway. The planks will sink, shift, separate under load. Kowalski has an idea. We scrape down to hardpan, lay coral base, then put the steel on top. How long will that take? 2 weeks? Maybe 3? We don't have 3 weeks. Crockett walks onto the muddy section, boots disappearing into the muck. He bounces on his heels. The mud ripples, but doesn't give way. There's something solid, maybe 8 inches down. Probably compressed volcanic ash from centuries of eruptions. We lay the planks directly on the mud. Let them float. That's what the Navy engineer said. Treat it like a raft. Sir, that's insane. Yeah, so's everything else we're doing on this island. They start at 1500 hours, 20 Marines divided into 4-man teams. Each team carries a plank, 2 men per end, and places it perpendicular to the runway's center line. The first plank sinks 2 inches into the mud before stabilizing. The second plank interlocks with the first via the curved lip connector. It takes 3 tries to get it seated properly. The tolerances are tight and mud clogs the mechanism, but once it's in, it's solid. No movement, no separation. By 1500 hours, they've laid 50 planks, 10 rows, 5 planks wide, a steel carpet 30 feet wide and 100 feet long sitting directly on top of volcanic mud. It looks impossible. It looks like it should collapse under its own weight. Crockett tests it himself. He walks the length of the mat, boots ringing on perforated steel, listening for weakness. The mat flexes. You can feel it. A gentle gives under each step, but it doesn't buckle. The interlocking connectors allow the planks to move as a unified surface, distributing load across dozens of contact points. All right, he says, let's see if it'll hold a Jeep. They drive a Willys MB onto the mat at 5 miles per hour. The Jeep weighs 2,450 pounds loaded. The mat sags maybe half an inch, steel singing softly under stress, and then stabilizes. The Jeep drives the length of the mat, turns, comes back. No deformation. No planks pulling apart. Kowalski lets out a breath he didn't know he was holding. I'll be damned. Not yet, Sergeant. Get me a Wildcat. October 15th, 1942. 0830 hours, Henderson Field. Captain Joe Foss has seen a lot of crazy things since landing on Guadalcanal, but asking him to land a fighter on 100 feet of experimental steel matting might be the craziest yet. You want me to put a 5,000-pound aircraft on sheet metal? Foss stands at the mat's edge, arms crossed, studying the perforated surface. On purpose? On purpose, Crockett confirms. Normal landing, full rollout. We need to see if it holds. And if it doesn't, then you'll have an interesting story for the after-action report. Foss snorts. He's flown 63 combat missions in the past 2 months. He's been shot at by Zeros, bombed by Bettys, shelled by Japanese destroyers. Landing on experimental runway matting barely registers on his personal threat assessment. All right, clear the area. If this goes bad, I don't want ground crew getting hit by debris. He climbs into his Wildcat, same aircraft he wrestled out of the mud 3 weeks ago, and taxis to the southern end of Henderson Field. The mat is visible from here. A rectangular patch of dull gray steel, darker than the surrounding coral, sitting in the middle of the runway like a metallic island. Foss lines up, checks his approach angle, throttles back to landing configuration. Gear down, flaps down, airspeed 70 knots. The mat rushes up to meet him. Perforations blur into solid surface, and his wheels touch down. The impact sounds like a gunshot. Steel screams. The entire mat flexes downward maybe 2 inches, the interlocking planks moving as a single unit, absorbing and redistributing 5,000 pounds of force plus forward momentum. Foss can feel it through the control stick, a strange elastic give, different from coral or concrete, but the aircraft doesn't bounce, doesn't slew sideways, just rolls straight and true. He brakes. The Wildcat stops in 40 feet. Foss sits in the cockpit for a moment, engine idling, listening to the mat settle beneath him. Then he taxis off, turns, and lines up for takeoff. The takeoff roll is even stranger. The mat flexes under acceleration, steel planks rippling like water as the Wildcat builds speed. But there's traction, excellent traction. No wheel slippage, no bogging down in mud. At 50 knots, Foss pulls back and the Wildcat leaps into the air like it's been launched from a catapult. When he lands 10 minutes later, on the regular runway, not the mat, Lieutenant Crockett is waiting with a notepad. Well, it works. Foss climbs down from the cockpit. Feels weird as hell, but it works. How soon can you cover the whole runway? We've got enough matting for 800 feet, more coming on the next supply run. If we work around the clock, maybe 2 weeks for full coverage. Make it 1 week. Foss looks toward the northern sky, where Japanese bombers make their daily pilgrimage. We don't have to. October 28th, 1942, 0600 hours. Henderson Field. They finish at dawn. 14 days of continuous work, 20-hour shifts, sleeping in 4-hour rotations, laying steel planks through air raids and artillery bombardments and rain that never seems to stop. But Henderson Field is now 2,400 feet of Marston matting, interlocking steel planks covering the runway's most critical section, floating on volcanic mud that once grounded their Air Force. Gunnery Sergeant Kowalski stands at runway's edge, watching the first morning launch. 6 Wildcats and 4 SBD Dauntlesses, taking off in clean succession, wheels singing on steel, no mud spraying, no aircraft bogging down. The mat has transformed Henderson Field from a barely functional dirt strip into something approaching a real airfield. It's not perfect. The matting is noisy. Aircraft landings sound like rolling thunder. It requires maintenance. Planks work loose under repeated stress and need to be resecured. Tropical heat makes the steel hot enough to burn exposed skin. Mud still accumulates around the edges and needs to be scraped away, but it works. That's all that matters. By November, Henderson Field has 3,200 feet of Marston matting. By December, the entire runway is covered. The Marines stop losing aircraft to mud. Sortie rates triple. Japanese bombers start encountering fighter opposition every time they approach Guadalcanal. The tide of the Pacific War shifts, measured in perforated steel planks delivered by cargo ship and installed by exhausted engineers who figured out how to turn industrial steel into floating runways. The official designation remains pierced steel planking. The technical specifications fill 30 dozen pages of military documentation. But every Marine who served on Guadalcanal, every pilot who landed on that impossible steel carpet, every engineer who laid those planks in darkness while Japanese shells screamed overhead, they call it Marston matting. By war's end, Carnegie Steel and other contractors will produce over 2 million tons of it. It will appear on over 400 airfields across the Pacific and European theaters, Bougainville's volcanic beaches, New Guinea's jungle swamps, the coral atolls of the Marshalls, even temporary strips in France after D-Day. Anywhere ground is too soft, too wet, too unstable for conventional runways, Marston matting turns the impossible into the operational. James Marston never set foot on Guadalcanal. He never saw his invention in combat. He never watched a mud-caked F-4F Wildcat land safely on steel planks he designed in a Pittsburgh office. He just solved an engineering problem. How do you build a runway that floats? The answer was simpler than anyone expected. You stop fighting the mud, you build a steel raft. You interlock enough of them to support the weight of war, and then you win.